Alright, I'm going to do a little programming tutorial here. We're going to do a 5x5 augmented matrix solution. This is problem 17 from section 4.8, page 149, if you're using the classic version of the text. And the reason I'm doing this, we did this for 3x3 matrices, as you recall. I mean, 3 equations with 3 variables. And I just did it as simply as I could as far as making it easy to follow, but it was fairly tedious. Let me show you that there's actually some tricks of the spreadsheet that you can use that will speed it up a whole bunch. Okay? And so once you see how to use these new little tricks, you could actually see how it would be quite easy to do this, say, for 10 by 10 or something like that if you needed to. Okay, let's do this. So I'm going to start off the same as before. I put an equals to insert a formula. That tells the cell that this is going to be a formula. I'm going to take that number divided by itself. But look at this for a second. A4 divided by A4. When I come over to this cell, this one down here is going to be this number divided by A4. This one is going to be this number divided by A4. So the numerator, if I want to make a formula that I can copy straight across. And to do that, I have to make the numerator a relative reference. So as I move the cell to here, the numerator is going to point to that cell there, just like this one pointed to that cell there. So relative to this cell, this one is straight up. Relative to this cell, that one is straight up. But the denominator, I don't want to be. I want the denominator to be always that first column. So what I do is I put a $sign in front of the A in the denominator, which means this A is a relative reference. This is A because this is A, right? This A is going to be A no matter whether I drag the cell across or not. Let's look at it. So it says 1. Let's drag that cell all the way across. This one is now going to be B4 divided by $A4. This one is C4 divided by $A4. So it's always referring to A4, which is this 3 over here. So all of these are getting divided by not just itself, it's getting divided by the lead number in that row, the lead coefficient. So we got the whole row by specifying one formula. Let's go to the next one. This is going to be even more impressive. How did we do this? We said this is equal to, alright, let's just talk about it first. I'm going to take this row, and then I can easily manipulate this row because I have a 1 out in front. So for instance, if I took 2 times this row, this would become a 2. I could subtract and I'd get a 0, right? So I'm going to take this row minus 2 times this row. And where did I get the 2? It's because there's a 2 up front here. Okay, so when I say this row, I'm going to point to this here. Let's say equals. I'm going to point to this, meaning the first element of what I'm going to carry across. But the denominator, this is not denominator, it's subtract. So it's this row minus this number times this number. Now let's look at that. As I copy it across, I want this number to be that number times this number, right? So again, I want to have this, and I want to pin this down. Okay? Now I'm going to come back and change this in a minute because I'm just teaching you one thing at a time here. So notice that each of these is, again, we use the idea of referring to the lead coefficient by pinning down the column. Well, what do I want for the next row? It looks like it's an awfully similar process. Up here I reduce this number to a 0 by subtracting this multiple of this row. Here I want to reduce this number to 0 by subtracting a different multiple of this same row. So the formula is exactly the same, except I can't say this one and this one and then this one and this one. It looks like I'm going to use the same row down here each time. So let's go back to the formula and notice that this is A5 is $A5, excuse me, this is equal to A5 minus $A5 times A10. But the 10 I want to pin down because I want that to be the same for all of these formulas. So if I pin down the 10, notice I have the pinning down the A pins down this column, pinning down the 10 pins down this row, because that's the row I want to work with when I'm doing these others down here. So watch this. This formula will copy across all the way to here and all the way down to here. 1, 2, 3, 4, 5. We've got all of those rows for the price of one formula here. So I have one formula to get a leading coefficient of 1, and then one formula that will reduce this to 0, and the same formula reduces all of these rows to 0 here, because all of these are referring to row number 10, namely this row. This one refers to row number 10. This one refers to row number 10. Okay. Let's color all of these in. And now notice that only this amount is going to be active. This row and this column are never going to be touched again. So I'm going to change our active one to a slightly different shade of blue. Okay, next stage equals that. So I'm just copying down all the light blue area. So now I want to work in this smaller matrix. And we're going to do the same thing we did up here, except in a smaller scale. Wouldn't it be nice if we could come up with a formula once from up here, excuse me, for this one, that would transfer to here? Well, you might ponder that. If there is a trick so that not only can you do it for this, it's hard to know. All right, we're just going to do it. Here goes. Equals that number divided by itself, except we're going to pin down the denominator column. Drag it across. We have a 1 equals that one minus itself times this row. And I'm going to pin down this column. I'm going to pin down this row using the same reasoning as before. This will now copy for all the rest of the cells in the matrix. And now only this many cells remain to work with. Okay, let's say equals that. I'm going to copy this all the way across into the second row and to there. Okay, so all of these are simply copied from up there. So this one, so this region here needs to be transformed from here. So I want to reduce this one equals that divided by itself, pin down the column of the denominator, copy it across. This one equals that minus it's that number times this number. I'm going to change this to $1 and the number here, the row, to $1. So this copies across and then down. Okay. So we're down to just this 2 by 2. equals that. And these three go for 2 more. So all of these numbers, by the way, have exactly the same formula. This is A22, which is just a reference straight up. This one is C25, which is an equal reference straight up. So all these are copying straight down from the corresponding cell of the above matrix. So here are the ones we want to work with. Starting here, equals this number divided by itself, except with a dollar put there. Drag it across. This number equals this number minus itself times this. And I'm going to put a dollar here. I don't need the dollar here because we don't have any more rows to work with, but what the heck, let's keep the pattern the same. Drag it across, and there's one last thing to do. Notice we still don't have a lead coefficient of 1, so there's one last step. This one equals this one. Drag it across to here. Drag it. In fact, let's just drag it all the way down. Okay. Except these two I'm going to redefine. Okay, so this one I'll say equals this one divided by itself, except I'm going to put a dollar. And then I'm going to drag this across. Okay, so I basically copied something in there even though I was going to throw it away and copy and put something else in its place. So it works. We now have a finished matrix. Now, the last stage is we want to put the X, Y, Z business. We want to actually get our variables. Now, because I have a bunch of them here, I'm going to, instead of trying to come up with, do I want to call this W or V, W, X, Y, Z, something like that, I'm going to call them X1, X2, X3, X4, X5. Okay, let's make them bold, make them right adjusted. And so X5 is going to equal that number there. X4, this is the same pattern as before, and you can verify that it's correct. I'm just going to do it. So this one is equal to that number minus that number times Z, or the last thingy, whatever it was. This number equals that number minus that number times the last variable minus that number times the next to the last variable. This number equals that number minus that number times the last variable minus that number times that variable, that number times that variable. This one equals that number times that variable, that number I got all those right. Now these I could add a few decimal places maybe, even though these came out all even. Now what I'm going to do is I'm going to copy these. So Control X cuts it rather. I'm going to put these right up here. Even though even though I've moved these equations, notice these formulas in here, notice they still refer back. Okay. Notice they still refer back to, here's F34. Where is 34? It's way the heck down here. It's this row. So they're still referring to the same rows as before we moved them, except I was able to create them down there, but we want to look at them up here. So when you put in your input matrix here, let's make these bold. Let's color them pink. Let's type in solutions. Make that bold. Okay, we have a program. Notice it's convenient. We have our input. As soon as you type in your input, there are your solutions. Here's all our scratch work. You may never want to look at all that scratch work, but there it is. And so here you can do it for 5x5 matrix. All right, that wasn't terribly painful, at least if you're able to follow what I did.